everyone, and we are going to continue the chain rule. Hopefully after day 3 you have an idea of how to take the derivative fairly quickly now of a simple chain rule. Of course today, since this chain rule completed and we don't spend much time going over a concept, you know this has to be a little more difficult. So we're going to be doing the complicated chain rules. The first two here that we see are more simple, and then we'll get to the more difficult one as you can see underneath it. But let's again remember that the derivative of using the chain rule method is the derivative of the outside, keep the inside the same, multiplied by the derivative of the inside. And so if we look at this one, here's the inside, here's the outside. So the derivative of that is going to be cosine, keep the inside the same, multiplied by the derivative of the inside. And so we're going to get 2 cosine of 2x. And that's the answer. And so that's the easier one. If we look at this one, this is going to be a triple chain rule here because we know this 2 can really go out in front. And so we're looking for the derivative of sine 3x quantity squared. And we know that is going to be the derivative of the outside, 2. If we want to, we can put parentheses there. 2 sine of 3x, all to the first, we don't need to write that though, multiplied by the derivative of that, which is cosine, keep the inside the same, multiplied by the derivative of the inside, which would be right there. And so we finish that off with 6 sine 3x multiplied by cosine 3x. And that's the answer. Notice you cannot pull out a 3x there. It's something that people like to do. We cannot do that. So now let's look at the more difficult one here. Notice that we have the square root of x multiplied of the tangent cubed of the square root of x. You should be able to look at that and say, ooh, that is a product rule. We have 2 things being multiplied together. So the derivative, and one thing that you guys want to note here is that the derivative of the square root of x, and I apologize, I cannot, if f of x equals square root of x, you need to be able to know that f prime of x is 1 over 2 square root of x. That's going to make your life a lot easier in the next coming weeks and or the rest of the year if you can remember that. It's always going to be 1 over 2, and then keep the square root goes in the denominator with the inside. So with this one, we know that the square root here is 1 or the derivative of square root of x is 1 over 2 square roots of x. If we look at this one again, this can be tan square root of x all cubed. So the derivative of this is going to be 3 tan square root of x squared, derivative of the inside. And again, I'm using a mechanical pencil. I apologize that you cannot see that. I'll try to write a little harder here. Multiplied by the derivative of tangent, which is secant squared, square root of x, keep the inside the same, and then multiplied by the derivative of square root of x, which is 1 over 2 square roots of x. Okay, so turned off the hovercam light, and I know it's a little darker and not nearly as clear, but I think you'll be able to read the handwriting better on this. So where we were at was we take the derivative of square root of x, the derivative of tangent cubed square root of x. Let's make this a little nicer. We'll combine it. The 3, the 1 over 2 square roots, we're going to get 3 over 2 square roots of x. Keep everything the same at the top. So we are going to here cross multiply, do the derivative of the first times the second plus second times the derivative of the first. So we'll go there. So 1 over, square root of x multiplied by 3 over 2 square roots of x, tan square root of x, secant square root of x, plus those 2. So and what you should be able to notice here is that you can cancel those because they are being multiplied. So we're left with 3 over 2 plus, we'll just leave that as is. And that is our answer, if you can see that. There we go, that's a little brighter for you. So, moving on. Notice this one, it says find f prime of x given that f of x equals f of g of x. So, we know that f of x equals this part being plugged in there. So let's do that. 2 times x cubed minus 5 plus 3. And we'll write that out as 2x cubed minus 10 plus 3. And that is going to be 2x cubed minus 7. Okay, and so f prime of x is going to be the derivative of the outside. Again, 1 over 2. Keep the inside the same. Multiplied by the derivative of the inside. So 6x squared, and that's it. And we can reduce this to be 3. 3x squared over the square root of 2x cubed minus 7. Done. So moving on to the final example before we get into inverses here. We have a nice ugly one, it looks like. So we're just going to take the derivative of h of x. Let's try that again, before we do anything with the h prime of 1. So h prime of x, remember that's really on the outside. So 3, parentheses, f of g of 2x cubed, all squared. Multiply by the derivative of f. We only did the 3 there, so now I got to do the derivative of f prime of g of 2x cubed. That was the outside. Now on to g times g prime of 2x cubed. Now on to the inside times 6x squared. And we're done there. And so now the issue is that we have to find h prime of 1. So h prime of 1 equals 3 times f of g of 2. I hope that you guys can all see that 2 times 1 cubed is just 2, so we're going to leave it as 2 there. So 2 squared times f prime of g of 2 multiplied by g prime of 2 multiplied by 6. And so we are going to get g of 2, which is 3. So 3 times f of 3 squared. G of 2 is 3 again, so we're going to get f prime of 3. G prime of 2 is negative 4, so times negative 4 times 6. F of 3 is 5, so 3 times 5 squared. F prime of 3 is negative 2, negative 4, and 6. And we're going to get 3 times 25, which is 75, times negative 24 times negative 2, which gives you 48. And so you get 3,600, I believe, is the answer. So that's the other part of chain rule. Now the other concept that we're going to look at here is the derivative of an inverse function. And this can get a little tricky, and it shouldn't be that bad if we think of the rule that you learned last year, that an inverse function, the inverse function is f of f inverse of x needs to equal x. It's a composition. So if f is a differentiable function, then the inverse, then f inverse is the inverse, and then that is true. So if you understand that, if I take the derivative of f inverse of x equals x. If I take the derivative of all of that, then I do a composition here, so I do f prime of f inverse of x. That's the derivative of the outside multiplied by the derivative of the inside. F inverse of x, the derivative of that, equals 1. Because the derivative of x is 1. If I'm trying to solve for the derivative of the inverse, which is what the title is here, if I'm trying to solve for that derivative, I'm going to divide this part over to that side. 1 over the derivative of the inverse. This is something that will be good to memorize. That the derivative of the inverse of x is that. So let's just look at an example here, and we'll probably end off on this page and not do the next page. If f of x is that, we know f of 1, and I hope that we can just see that f of 1 is 1 plus 2, which is 3. And the derivative, if f, the derivative is 4x cubed plus 6x squared. So f prime of 1 equals 4 plus 10, which is, or 4 plus 6, which is 10. So now the goal is to remember that the inverse is reflected over the line y equals x, and so x and y are switched. So if we have the point 1 comma 3, and we switch that to be 3 comma 1, we know that f inverse of 3 is 1. And so what we're looking to find is the derivative, and I know you can't see it well, but there is a derivative symbol there. We need to find that. So if we are looking for the derivative of f inverse of x, we know we're going to use this method of 1 over f prime of f inverse of x. And do we know what f in, if I'm looking for 3 here, do I know what f inverse of 3 is? Well, yeah, f inverse of 3 is 1. So I can say that that equals 1 over f prime of 1. Because that's what this is, 1. And now do I know what f prime of 1 is? Yep, I found that up there. That was 10. So our answer would be 1 over 10 then. And that is, it's, I know it doesn't look very useful, but that would be how you do it. So the last example here, if f of x equals 4x minus 2 and g of x is the inverse function of f, then we're going to find the derivative of the inverse, another way of just saying f inverse prime of negative 8. So when we do that, we are going to find f of negative 8. Well, sorry, we know that f of, let's try this again. We know that f of 0 is negative 8. So then we also know that f inverse of 8 is negative 8 is 0. That's just the inverse. We know that f prime of x equals 3, parentheses, 4x minus 2 all squared times 4, the derivative of the outside times the inside. Okay? And we can also say that the derivative, well, I guess we probably should wait for that. We're going to have to find that. So to save time, I already wrote what this is, and you can pause it and figure that out. But the inverse of 8 is 0, so we know that we're going to look at f prime of 0. And so now we can finally plug this back in and get 12 times negative 2 squared. So we're going to get 12 times 4, and get 48. And so you're left with 1 over 48. And that would be the... And due to Alana's request, here is Seth. Seth.
Hi, Seth.
Hey, Seth.
Hi, everybody.
You say hi?